For this lesson, we're going to look at one-to-one function and also inverse functions. So we want you to be able to find both once this is done. All right, one-to-one functions. They are functions that don't have x or y values that ever repeat. So we know about functions. We had that vertical line test to see if something's a function. That means if it's a one-to-one function, it's going to pass the horizontal line test. If you draw a horizontal line through, you should not have any repeated y values. And so if you want to see that something's one-to-one, check that there's no x or y values repeated. This first one's an example of one that is one-to-one. Notice none of the x values repeat, and also none of the y values repeat. So that's what makes this a one-to-one function. The bottom example is it's a function. Okay, none of these x values repeat, so it is a function. However, it's not one-to-one because, as you can see here, we have the same y value in both those places. So that's a function, but it's not a one-to-one function. Okay, for here, we want to check, are these one-to-one functions or not? So remember, vertical line test tells you if it is a function. This passes our vertical line test. We only hit the graph one time. Is it a one-to-one function? Then it has to pass the horizontal line test. So if we draw a horizontal line, does it just hit once? In this case, no, it hits 2 times. So this is not a one-to-one function. It is a function, but not a one-to-one function. All right, let's look at B here. The graph of y equals 3x minus 4. Is it a function? Yep, passes our vertical line test. All our vertical lines only hit once. Let's check our horizontal lines to see if it's a one-to-one. Do we see it hitting more than once anywhere? Nope, it only hits once. So this would be an example of a one-to-one function. This is a one-to-one function. So yes, this one is. All right, if you want to check on these ones if something is one-to-one, then use your calculator and take a look at the graph and see what the graph looks like. So again, the graph, we go to the y equals menu, clear out any functions that are there, and then type in the function that you want to see graph. So we want to graph out x to the 3rd power, and then hit over and minus 1. All right, let's take a look at this graph. So if we graph this one out, there's the graph. Does that graph pass our vertical line test? Yep. Does it pass our horizontal line test? Yes, it passes both. So is this one a one-to-one? Yes. Okay, well, let's look at B. Okay, so let's graph that one out. So again, clear out the function that's there. X squared plus 3. So if we look at this graph, looks like it's a parabola. Does it pass our vertical line test? Yep, it is a function. Is it a one-to-one function? No. If you look at a horizontal line here, it hits 2 times. So this one is not a one-to-one function. All right, inverse functions. If a function f of x is one-to-one, so like we just talked about, one of those one-to-one functions, where with a domain A and a range B, then if you find its inverse function, the domain and range switch. The domain becomes B and the range becomes A. So in one-to-one functions, whatever your domain, whatever your x's is, that now becomes your range, your y's, and same with the range and domain. The range of your function becomes the domain of your inverse. Okay, so what that means is if you have the function f of x equals y, if you find the inverse function, that's our notation for inverse, and you plug in y, you should get out x, because the domain and range flip. Okay, let's look at that, what that would mean with some example problems here. All right, so in example 3 here, it says assume f is to be one-to-one. Find the different values. So on example A, they tell us f of 1 equals 5, f of 3 equals 7, and f of 8 equals negative 10. what are the inverse, what is the inverse at 7 and what is the inverse at 10? Well, these values over here told us if we had a table and you got x and f of x or y, if you plug in 1, you get 5. If you plug in 3, you get 7. If you plug in 8 to this function, you get negative 10. Well, inverse flips it. So that is saying if we did the inverse at 7, that's our y value or our f of x value, f of x or y here, they're going to switch. So now this, if we plugged in 7, it should bring us back to the value we just had of 3. And so we know the inverse function at 7 should equal 3. If we did the same thing here, the inverse function at negative 10 then should bring us back to 8 as long as this is a one-to-one function. Okay, pause the video and want you to try out B and C and see what you come up with for both of those. All right, let's check here. If you're doing this one, if f of 3 equals 8, that means the x value is 3, the y value comes out to be 8. If you're finding the inverse, that's then our y value. So this should equal 3 since you're just moving back to that value. With the next one, inverse at negative 3 equals 1. So this is inverse. That means this is the y value. That's the x value. So if we want to find the function at 1, that's our x value. This should equal the y value associated with this one of negative 3. So inverse takes you back to where you started. All right. This one says, assume these are one-to-one, find the values. Okay, so here we're given a function. We want to find what's the inverse at certain values. But here we're not told what value gives us this. But we know if this is an inverse, inverse is going to have y as its input, not x. And so what we know is this is a y value. And so if we want to solve out what is the inverse at 7, we have to put this y value in for f of x or y and solve that out. So we got to figure out what's the x that'll give us that. So if we put 7 in for f of x or y and solve this now for x, we can figure out what that would be equal to. So now to solve that, add 1 to both sides, divide by 2, and we get 4. And so this inverse right here, if we want to figure out what is the inverse of this function f at 7, it should equal 4. And the reason is if we would plug 4 in here, that should equal 7, and it does. 2 times 4 is 8, 8 minus 1 is 7. All right. On the next one then, find the function, inverse function at 10. So doing something similar here, if we put in 10 in place of f of x and solve this out, we want to find what's that x value that would equal 10. Add 1, divide by 2 again. Here it looks like 5.5 or 5.5. And so this inverse at inverse function at 10 should equal 5.5. All right, why don't you pause the video, try B out, and see what you get for B. All right, let's see what you came up with. What's the inverse at 3? That's telling us the y value here equals 3. What's that equal? To solve that, we could subtract 2. That would give us 1. Notice that we still have negative x left, so now we'd have to divide both sides by negative 1, meaning x is going to be negative 1. And so the inverse function at 3 equals negative 1. All right, for the other one, find the inverse at 0. So now you put 0 in place of that and solve it. So if you put 0 in for f of x and solve this, you could do this one. Another way of solving this one, rather than subtracting 2, another method we could use would be to add x. That actually gets us, looks like, to the answer quicker here. X would equal 2. And so the inverse at 0 equals 2. All right, for this one, they give us three ordered pairs that are part of a triangle, and this triangle would be one-to-one since we don't have any, or actually it's not in one-to-one because we have repeated y values here, but we can still find the inverse even though it's not a one-to-one function. So first let's graph those points. Okay, 2, 1, okay, remember that's an x and a y value. So 2, 1 is right here. 5, 1 is right there, and 2, negative 4 is right there. So if we connect those, forms a nice little right triangle here. Okay, we want to find the inverse. Now remember, inverse kind of switches around the x and y values. So the inverse values to this would be 1, 2, 1, 5. So just switching all these ordered pairs around, and negative 2, or negative 4, 2. So now let's graph those inverse values here. So if we graph these ones, 1, 2 is right here. 1, 5 is right there. Negative 4, positive 2 is right there. Notice this is also a right triangle. It's the same shape as the other one, but it's in a different location from the original. Back in geometry, you talked about different types of transformations, moving one shape to another place. And the ways you could do that is a translation or slide. That's not what we have here. We can't slide that red one over to make that green one because it's not oriented the same way. You talked about rotations. This one, I don't know that it's a rotation. Maybe if we had a certain center, we could get that. But this one to me looks like a reflection. Remember reflections where you flip the shape over a line. And the line that we would be flipping this over would be this diagonal line through the origin at a 45-degree angle, which is the line y equals x. And that's not a coincidence. It's because y equals x is where y and x are the same value. What did we do to get all these pairs here? We just flipped the x and y around. So they're all going to be a reflection over that line y equals x. Okay, find the inverse. So these problems now want you to actually figure out what is the inverse function for each of these. Remember, inverse functions should do the opposite. So this is the function f of x equals 3x plus 2, or we know f of x is the same as y. If you want the function that does the opposite, instead of a y equals equation, you want a x equals equation. So our job is to solve this function instead of y, solve it for x. So we want to do the opposite of everything over on this right side. So let's start by subtracting a 2. Now we want to get rid of the 3. It's being times by 3, so do the opposite. Inverse does the opposite, so divide by both sides by 3. And now we have x equals y minus 2 over 3. That would be the inverse function of this one. Okay, if we plugged in the y value, we could now find the x value. If you want to write it in that function notation that we had before, then it would look like this, that you have the inverse would equal y minus 2 over 3. So that would be using that inverse notation. Okay. Let's try another one here. Find the inverse here. Okay, again, f of x is like our y here. So we want to solve this for x to find the function that does the opposite. So first step here, let's plus 1 to the other side. Okay, now similar, we want to divide, get that number out of here, divide by 3. Okay, but we're still not quite done on this one. We still got that power of 2. So think back, how do we undo powers of 2? That would be 2 square root. So we want to square root both sides here. So now we should have our answer here. On the right side, we just have square root of x squared would just be x. On the right side now we got the square root of y plus 1 over 3. This would be the inverse function here. We could now plug in the y value to find the x value. All right, why don't you pause the video, try it out, number 6 here, example 6, and see what you get. All right, let's see how you did. F of x is the same as y again, so our goal, get x by itself. First step, and this one we can't add that 3, it's being divided by 2, we got to do that first. If opposite of dividing by 2 is to times by 2, we want to multiply both sides by 2 here. So now we got 2y equals x to the 5th minus 3. Now we can add that 3 over. I'm going to move it up here. So now we got 2y plus 3. We can't put those together to get 5 because they're not like terms. Equals x to the 5th. Okay, last step, now we got to get rid of that power of 5. How do we get rid of power of 5? We can't square root. Here we want to do the 5th root. 5th root undoes a power of 5, so we want to do the 5th root of each side. And so x is going to equal the 5th root of 2y plus 3. Or in that inverse notation, that would be the 5th root of 2y plus 3. So one of those would be acceptable. All right, number 6, find the inverse of this one. Okay, so again, f of x is like our y here. We want to solve and figure out what the inverse is. Now, what makes this one a little bit more difficult is we got 2 x's involved. Okay, so we got to figure out a way to do that. First thing, let's try not to be working with fractions here. So like we did in the last problem, when something's being divided, let's times. Here we got times both sides by x minus 2. Okay, that'll cancel out on this side. So now we got x minus 2 times y equals x plus 3. Again, our goal, try to get the x by itself. So let's distribute over here. We can multiply this to both. And if we do that, we got x times y minus 2y equals x plus 3. All right? Well, how do we get, if we got to get x by itself, how do we do that if there's 2 of them? Well, let's try to get them at least to the same side. So I'm going to add 2y over to the other side since it doesn't have an x. And I'm going to subtract this x over since that term does have an x. So if we switch those two terms around, here's what our problem looks like now. This side, the x over here now is gone. So we got 3 plus 2y. Okay, so we're getting closer. But we still have these 2 x's. How do we get that to just be 1x? Well, if both terms have that, we can go back to some of the stuff we were doing before. We can factor it. If you factor out an x, then you're going to only have 1 in the problem instead of 2. So we got to figure out what's going to be remaining if we divide out an x out of both of these terms. Well, in the first term, if we divide out an x, what's left is y. If we divide out an x in that second term, there won't be anything remaining, but we'd have to put a 1 there, because remember, when we distribute, we'd have to get what we started with. All right? So now this should be 2y. We can solve for this by doing some division. We're solving for the x. Let's divide both sides here by y minus 1 now, and we got the answer. And so what we would get is that x equals 3 plus 2y over y minus 1. That would be our inverse function. Again, if you write it in that inverse notation, it would look like this. So this function would do the complete opposite, or bring us back to what we started with if we're a one-to-one function. All right, you're going to try out some of these out of the book here. So you're going to be determining if something is a one-to-one. Remember, that's if there's no repeated x or y values, and find some inverse functions as well. So the ones you're trying out here out of the book on page 230, 2 through 20, and 32 through 40, the even problems.